Out of the Fiery Furnace is brought to you by a company that makes aluminum for transportation, construction, and manufacturers of consumer products all around your house. Commonwealth Aluminum.
Il n'est pas parmi les emmurés de Salvador, là. 1000 emmurés, femmes et enfants bombardés. Et le pape, il est là dans ça. Quand il va quelque part, il voyage. Il arrive quelque part au Philippe.
This is the Pompidou Center in the heart of Paris, the anatomy of the 20th century exposed. It speaks for our time as the Crystal Palace spoke for the 19th century. It's a visceral display of function in architecture, an apotheosis in which man's by now intestinal involvement with the age of metals shows up like a barium meal. The Pompidou Center is a point of departure from all the surrounding traditions. It was not built up by craftsmen laying stone upon stone, but assembled like a motor car from steel components made elsewhere by machine. This confident rejection of traditional building materials argues that metals which have displaced every natural thing in almost every artifact that man uses are now ready to provide his habitation. Whether the Pompidou Center is a folly or a forecast depends upon answers to questions of the present. Are there enough metals left on Earth? Will society still accept the environmental penalties? And what will we use for energy if all the world is to be carried forward into the age of metals? For 10,000 years, metallurgy has accompanied the march of man, transforming his way of life, filling his material universe, yet never quite losing touch with its ancient origins. The passenger jet is still barely 30 years old, but it is among the highest reaches of the art of man the metalsmith. And yet the very core of this new technology, the turbines in the fiery furnace of the engines, are made by one of the most ancient ways of working with metal, lost wax casting. The original method of lost wax casting, which dates from at least the 4th millennium BC, is still being taught at Tokyo University. It begins with a wax model, in this case a replica of a bronze mirror from the Imperial Palace, nearly 1,000 years old. At its plant near Washington, the Howmet Turbine Corporation uses the same ancient process to make the turbine blades which drive almost 2/3 of the world's jet aircraft. Here too, the process begins with models shaped from wax. For all the advances of the past few thousand years, only lost wax casting can give these parts the strength to survive in the ferocity of their environment. The wax mirror is coated first with liquid clay, the first step in making a mold around its shape. The wax turbine blades, assembled in clusters, are dipped like chocolates in a bath of clay. The build-up of the mold continues with layers of coarser clay to make it stronger. The blade molds are strengthened with showers of ceramic particles. In the final shroud, a small hole at one end leads to the wax model inside. In their base, the blade molds too have an opening to the wax core. When the mirror mold is fired, the wax runs out, is lost. The clay shroud is baked hard. The blade molds are fired in a gas furnace. With the wax inside now lost, the ceramic coating is fused into a rigid shell. What emerges from the firing is a mold which contains a void, exactly matching the shape of the original wax model. The metal for casting the mirror is bronze, 90% copper and 10% tin. The same mixture that metalsmiths 4,000 years ago hit upon as ideal for strength, appearance, and ease of casting. This metal is a triumph of modern alchemy, an alloy of a dozen elements that will freeze into a single crystal of matchless strength, an already shaped and finished turbine blade. This is the industrial sculpture of the 20th century. Bronze replicas of the Emperor's mirror are destined for museums. Maybe, like their ancestors, they too will last for 1,000 years. Turbine blades will live for only a few thousand hours, but millions of lives depend upon them every day. In the long journey from simple shapes cast in clay to flight between the continents, there have been countless impulses and inspirations. One unflagging stimulus has been the search for liberation by wealth and emancipation by richness. That urge has driven civilizations to the edge of the known world for the shining prizes hidden in the earth. This is one of the world's far corners and one of its wilder shores, almost at the ends of the earth. It's the west coast of Tasmania, as unmarked now as when Abel Tasman first sighted it more than 300 years ago. But the hills behind the coast have not escaped so lightly. In the closing years of the last century, rich lodes of copper were found beneath the primeval forest, which then covered this whole region. Those who are animated by a contempt for our present existence could hardly fail to point out, here in the middle of what is still largely innocent nature, this instructive symbol. This lunar landscape was created by men for the smelting of copper. The trees were cleared from the hillsides to feed the furnaces down in the valleys below. The fumes from the smelters killed off the surrounding vegetation and prevented the regeneration of the trees, and the heavy rainfall did the rest, scouring away all the topsoil. And not many will dispute that the result was a supremely awful man-made blight, a scar which represents the more unthinking excesses produced by man's voracious appetite for metals. For a good deal of its history, most of its inhabitants have believed that the world was coming to an end. And many would see in this that ominous and harsh conjunction of events which conjures up the popular nightmare of a planet made in the end uninhabitable by the consumer society and its stimulation of what are held to be unnecessary needs and wasteful appetites. One might think that the passing of so many centuries without the forecast apocalypse would instruct us to be more confident. But the language of prophecy has continued into our own secular age, and it finds a popular echo in the environmental concerns and alarmism of the present time. It's an ambivalence which has accompanied mining and metallurgy throughout the thousands of years that man has been using metals. The difference is largely one of scale, and that is growing larger and more visible. It embraces the conflicts and the promise of our metal-dependent way of life, and the price that we've chosen to pay for our passage from the Stone Age to the age of metals. The sheer extent of devastation here has made it, for some years past, a tourist attraction. The hillsides are slowly starting to recover now that smelting has stopped, but it was a long illness, and it's probably true to say it couldn't happen now. New attitudes on all sides make it unacceptable, and modern technology makes it unnecessary. The industrialization of human society and its appetite for minerals has sharpened the conflict between needs and costs. That conflict is a volatile political reality in the urban sprawl of Western Europe. And here the environmental concerns have produced impressive community solutions. This is the largest power station in Europe. It burns brown coal and is one of a chain which generates 1/3 of West Germany's electricity. The fuel, more than 100 million tons a year, is mined by open cut from a coal bed near Cologne. To get at the coal, which in places lies underneath 200 meters of overburden, the Germans have developed the largest mobile land machines ever built. These gargantuan mining tools weigh up to 13,000 tons. They bite out 1 million tons of earth and coal a day. The coal mined here is inseparable from Germany's sustained industrial preeminence in Europe. But this vast gouging and overturning of the landscape occurs in the heart of what is still the richest farmland in Germany, the floodplain of the Rhine, which has been settled since the days of the Romans. In this instance, the opposing interests of town and country are resolved in a harmony of opposites. Evisceration of the earth is followed by its total restoration. As the huge machines crawl over and devour the landscape, the inhabitants of farms and villages move on into new farms and new villages, built on areas already mined and filled in. Everything you see in these pictures, villages, farms, the countryside itself, is restoration. Where farmland is concerned, the mining company replaces the rich topsoil and reconstitutes its fertility. The people buy these new properties with the compensation for the old. The old simply vanish during the mining until they, in their turn, are renewed. More than 25,000 people have been moved and resettled in this part of Germany. The entire cost is borne by the mining company, with the state government providing an added seduction of civic improvements like new schools. All this is part of the price of coal to the power stations. But for West Germany, this energy is still cheaper than oil from OPEC or Britain's North Sea fields. The inevitable blight of a heavily industrialized area like the Ruhr has been softened and living made more pleasant. 1/5 of the mine land is sculpted and planted with trees, and so a new landscape has been called into being. This is where mining and restoration first began 50 years ago. For a new generation, the deception is complete. Only a handful can now remember when this forest and this lake were one vast hole in the ground. But total restoration of this kind isn't ideal. Because of its cost, it is in most cases a rainbow which recedes. There's another way of containing the impact of mining. It's to make less profligate and more lasting use of the metals already won and processed. Scrap steel, copper, and aluminium are being recycled in greater quantities than ever. With precious metals, the incentive is obvious. These bars are stacked in the vault of the largest customer for silver in the world. This one American company consumes half the total amount of silver available in the United States, and more than all the silver used by many countries, including Britain and Germany. While silver was one of the first metals to be worked by man, it had a restricted use for centuries. But precious metals, too, were caught up in that great Niagara of applied technology, which swept over America towards the end of the last century. One of the most outstanding examples of the American instinct for popularization was invented by a bank clerk named George Eastman 100 years ago. In the 1880s, photography meant coming to a studio and sitting more or less paralyzed in this for about 20 minutes. That was the time it took to make a single exposure. And at the end of that time, the subject was rewarded with a faint portrait on tin plate. And the result was invariably cloudy rather than bright. To take photographs outside the studio meant lugging around cumbersome cameras and exposing pictures on heavy glass slides treated with volatile chemicals, and the snapshots had to be developed on the spot. As more and more Americans became more and more equal, so the demand for material possessions became more general and extensive. Quantity rather than quality became a criterion, and the cheapness which put things in the hands of ordinary people became a great element in success. With his invention, Eastman succeeded in assuring Americans that he had found a cheap and easy way for them to keep a record of themselves and their experiences. What Eastman finally devised was this: a box with a simple lens at one end. What went inside it was revolutionary. A flexible strip of the new plastic, celluloid, coated with chemicals. Eastman's device was not only light and convenient and cheap, it embodied a priceless virtue. It was foolproof. And because it all depended upon the reaction of silver nitrate to light, photography aroused and has maintained the world's largest appetite for silver. There is a corollary to this huge demand for a precious metal. Side by side with the mass production of film, the Kodak plant in Rochester in New York State conducts a huge salvage operation to retrieve the silver. From those passing moments, caught in countless snapshots and films, the company distills a source of permanent wealth. It recovers more than 600 tons of silver a year, worth hundreds of millions of dollars. Silver, like gold and some other inert metals, is indestructible. It can be cycled and recycled indefinitely. The demand for it is greater than ever. It's an ideal conductor of electricity, and it's become indispensable to the booming electronics industries. It has taken man some 5,000 years to mine perhaps 1 million tons of silver. But no less than half of that has been dug out in the last 100 years. The same pattern is reflected in the demand for all the major metals. That demand has been doubling every 20 years or so. And yet geologists are agreed that the danger of running out of metal resources is illusory and has never been less likely than it is today. The historical argument is powerful. Demand has always fostered innovation in search and discovery. Like the big game hunter used to do from the high vantage point of the howdah on the elephant's back, the geologist rides around the world today looking for the bands of mineral wealth which, striped like the tiger, run across the continents of the world. They can be visible and invisible to the human eye, but they can be found from up here. Those parts of the Earth's surface not covered by the oceans, which have yet to be closely looked at, are becoming more and more limited. And the reserves of mineral wealth which lie in the Earth's crust occupy only a tiny fraction, less than 0.1% of the continental areas. And they make small and elusive targets. There are bullseyes of copper and uranium, whose presence can only be sensed by the modern divining rods, the electrical and magnetic pulses that probe beneath the planet's old and wrinkled skin. And as the geologist rides higher and higher, his perspective has widened. Today, he stands outside the Earth itself. Photographs from space made in various wavelengths across the spectrum, from visible light to infrared, can differentiate geological features. There is a total of mineral resources on the planet which is finite, but there's little idea of its true magnitude or indeed where those resources lie. The great Australian emptiness It's the last of the inhabited continents to be explored for minerals, even now has hardly been scratched. It's only since the Second World War that this, one of the oldest landscapes in the world, the Pilbara in Western Australia, has been looked at closely. The prospectors were rewarded with an expanding horizon of iron. For those who believe that continued growth and progress, whatever their virtues, will prove impossible because the world is running out of resources, this place, Mount Tom Price, a single peak in a vast province of iron hills, teaches a mineral lesson. Australia's reserves of iron ore have been proved to be 100 times greater than those upon which the nation's domestic and international policy was based only 30 years ago. This discovery, together with more immense finds of uranium and copper, have confirmed Australia's rapid transformation. The golden fleece, which kept Europe warm and made Australia rich, is being overshadowed by the minerals which feed the furnaces of Japan and keep Australia rich. Throughout history, it's been local mineral wealth which has made first one nation rich and then another. Athenian Greece financed the Golden Age and paid for the wars in the ancient world with the silver it mined. Alexander the Great funded his conquests with the gold of Macedon. In the recovery following the Dark Ages, it was the mines of Germany which laid the economic foundations for that revival of confidence and of learning which led to the Renaissance in Europe. Britain became the world's leading power, coincidentally, with its leadership in the production of tin, of copper, of iron, and of coal, and the Industrial Revolution. And the far greater resources of the United States, more than twice the mineral wealth previously mined in all history, sustained and supported its advance to become the richest nation on earth. Today, the global village is less disposed to look upon the haphazard distribution of mineral wealth as a lottery with big prizes for a few winners. Access to raw materials is a long historical envy. It is vital to the advanced countries and becoming vital to those at the threshold of industrial revolution, like the new independent nations of Asia. For Australians, the occupation of a treasure house of minerals is likely to prove the most formidable responsibility in their history. There are other uncertainties. These mining operations, where the miner himself lives on and off the job in an air-conditioned comfort undreamt of by all his predecessors in history, assume inhuman proportions. They dwarf the individual by their scale and dimension. And there is no shortage of those who believe that this kind of gigantism must limit the citizen in his own pursuit of social ends. There's growing resistance to the prospect, which they see implicit, of all nature reduced to this kind of mechanical servitude in the name of material progress. That perhaps conveniently forgets that other servitude which once enslaved all mankind and still holds back the greater part of it. The tyranny of daily labor in the fields for bare survival. But to be here is to be aware of perhaps an even more significant change in balance. It is to dare to speculate that, consequent upon Australia's great boom in mineral resources, the center of gravity in the world may be shifting, that it's moving away from Europe and the older world, and that just as those once great mines in Spain sustained the ancient civilizations around the Mediterranean, of Rome and of Carthage, so now we're seeing around the great rim of the Pacific, from Japan to Australia and the United States, the rise of a new conglomerate of vitality, influence, and power. Australia's raw materials and the industrial heritage of America are fused together in the nucleus of a new prospect, the Pacific century. In an unrivaled synthesis of all previous technology, Japan stands on a new plateau in the mechanization of work. It represents as big a jump from Henry Ford's assembly line as that was from Britain's Industrial Revolution. The new Industrial Revolution is moving into uncharted seas in its social consequences. But it foreshadows the eventual release of men and women from the bondage of dangerous, arduous, or simply tediously repetitive jobs in underground mining, metal foundries, chemical works, and factories. These first-generation robots are the unskilled laborers of the new workforce, tireless and obedient. They're uniformly competent, yet crude. But already they're being refined and cultivated. For centuries, the craft of the watchmaker was among the pinnacles of skilled workmanship. But it's not been able to survive the onslaught of this industrial equivalent of gunpowder against castle walls. The silicon chip, with its nervous system of 15,000 integrated circuits, is the brain of the quartz watch. In the final assembly, life is breathed into the inanimate. The brain is harnessed by its robot creator to the body of the watch with threads of molten gold. Nearly half the gold mined in the world finds its way into the proliferating electronic empires. The progressive replacement of human labor means that industry is becoming increasingly dependent upon energy to take its place. The mining, smelting, and processing of the metals which make modern civilization possible now accounts for 1/3 of the world's total consumption of energy. Since the rise of OPEC, the Japanese steel industry has sought protection from that sudden vulnerability in a frantic campaign to conserve energy. This steel plant, the newest in Tokyo, has found a way to supply its own power. Instead of going up the chimney, and so to waste, the gases from every furnace and smelting process are collected and piped to a central power station. Here they're burned again to generate electricity. Waste heat is also used to make all the steam the plant requires. Surplus steam from that process is itself used to make more electricity. And so this very large steelworks, producing 10 million tons of steel a year, has been made entirely self-sufficient in power. The OPEC earthquake made all the giants tremble. America, once the world's greatest oil producer, had developed by the 1970s a thirst for petroleum which could be satisfied only by a flood of imports. When the price of oil quadrupled, the Americans not only set out to find more of it, but seized their own oil fields by the throat to wring every last barrel out of them. Even Century City, in the heart of Los Angeles, has been reminded that it's perched above an old lake of oil. This alien spire in a field of office blocks conceals a full-size drilling rig. It's one of scores of new wells which the present world prices have made profitable. And so, oil is pumped from the very basements of America's largest city. In that shrine to unreality, Hollywood, California, it's unsurprising to find that this building on West Pico Boulevard encloses a minor oil field. Inside, there are 40 producing wells. There's a lot of oil still left under Los Angeles, as there is in old wells all over the world. But the day will come when the cost of these last-ditch operations will rule them out. Then there will have to be a supplementary source of energy, even to maintain the present living standards, let alone to meet the rising aspirations of the world at large. One of the first impulses has been to reach for the sun, as the ancient civilizations did. There is a certain nostalgia and comfort in that receiving warmth. Unlike the older technologies for producing energy, this one is eerily quiet. There is no pollution of atmosphere, earth, or water. Solar One in the Mojave Desert in California is the first large solar generator to make a contribution to commercial power. It's expensive, but it works, and there will no doubt be more like it. However, solar energy is obviously intermittent, and it is for the day, not the night. It's not likely to provide more than 5% of the world's energy needs before the year 2000. The one new source of energy discovered this century that might sustain us in the next is at present under fearful scrutiny. The cooling towers of the 3 Mile Island nuclear plant in Pennsylvania have thrown a long shadow across the most accessible path to atomic energy. The unlocking of the great doors to the heart of matter stands as the most formidable material achievement of the human intellect. The radioactive metals transcend in their possibilities all the other metals man has ever put to work. The energy from a single lump of uranium can match the output of 300 coal mines in Britain or 50 kilometers of open-cut mining in America. A dramatic alternative beckons, therefore, to the burning of fossil fuels and the growing apprehension about their consequences, such as acid rain. But the most advanced technological civilization the world has known is hesitant at the threshold of a new age. It was at this place, in the desert of New Mexico, surrounded by the outcrops of extinct volcanoes, which bear witness to nature's own, at times, surpassing violence, that on a July morning in 1945, man lit his last and his most fiery furnace. It was an ultimate successor to all those furnace fires of his, which have glowed throughout recorded time, and in which he has sought to forge both his weapons and his wealth. Here it was that man succeeded for the first time in reproducing on Earth in an instant the furnace of the sun. He did so in those generations of fission which took place in a billionth of a second, here on the site of the world's first atomic explosion and the rehearsal for the destruction of Hiroshima and Nagasaki. These were the last moments in the Garden of Los Alamos before the 20th century Adam reached for a new dimension of knowledge and power. Under Dr. Robert Oppenheimer, an international concentration of scientific intellect was yoked to the war effort and had worked against time to test the feasibility of an atomic bomb. On July the 15th, 1945, it was hoisted slowly to the top of the tower. At 5:29 the next morning, the desert was lit, as Oppenheimer chose to say. brighter than 1,000 suns. A huge saucer of sand was fired into silicon beads by the melting of the desert floor. These are the pearls of Alamogordo. They represent the difference between the past and the future. The nuclear fire in the desert of New Mexico confirmed the arrival of the atomic age. The atomic furnace reversed the flow of all previous practice and experience. All the furnaces which preceded this one consumed vast resources, the forests, labyrinths of coal, underground oceans of oil, in order to make relatively small quantities of matter, of iron and copper and steel. The nuclear furnace was fed with small resources, but yielded vast amounts of matter in the form of energy. For all its exactitudes and its imponderables, the nuclear furnace was an intuitive recognition by man that he lived in a world of finite resources. Here, we might say, man gave up his wanderings in the deserts and the forests to turn to the ultimate source of energy, the sun itself. It was his greatest scientific achievement. It took him 2,500 years from the time the Greeks first considered the existence of the atom until that final Promethean feat lasting 27 months, in which he demonstrated here that he could manipulate the fundamental components of the universe itself, that with it he could forge and consume the new strategic precious metals, uranium and plutonium, which have taken the place of gold and silver in determining the relations between all-powerful nation-states. The scientists had the wit to call this place Trinity, choosing for it a name which has long stood for the highest, most mysterious and exacting of all philosophical and religious concepts and difficulties. Ever since Homo sapiens first used fire, he has been preoccupied with the nature of the gift. Prometheus, in Greek myth, the savior of mankind who took fire from the gods and returned it to man, denied him knowledge of the future. He thought it might make men unhappy and break their hearts. Alamogordo could be the altar on which the whole of Earth is offered up as some kind of burnt offering. But perhaps we ought to be more optimistic. In his monumental history, The Decline and Fall, a great human intellect, Edward Gibbon, reminded us that however much the opinion that the world is coming to an end deserves respect for its usefulness and its antiquity, it has not proved agreeable to experience. Nearly half a century on from Alamogordo, we are still here, however precariously. But there is more than just survival to show for it. Each new leap of technology may be shadowed with risk. But the challenge of risk has been indivisible from civilization's march. From the time when the perspectives of man were measured by the distance he could walk in a day, to his vistas now, out among the spheres.
My name is Robert Raymond, and I'm the producer of this series. And I'm going to raise a question which I think might have occurred to many people who watched this final episode. Is the world going to run out of metals? Here we're in the mountains of Colorado. The metals found in these hills and valleys in the 19th century, those bonanzas of gold, silver and copper, were a key factor in the foundation of the modern United States economy. Today, most of those rich deposits are gone. Is this going to happen one day to all the great mines of America and elsewhere? Someone who has positive views on this is Dr. John Tilton, Professor of Mineral Economics at one of the chief centers of knowledge on this critically important issue, the Colorado School of Mines.
Well, I don't think the world's going to run out of metals, at least not in the sense that one day we'll wake up and find the cupboard bare. The U.S. Geological Survey, for example, has estimated we have 1.5 times 10 to the 15 tons of copper in the Earth's crust.
What does that come to?
That comes to roughly 200 million years of use at current production levels, which is far more than most of us think we need at the present time. And I might also add that copper is a relatively rare metallic element in the Earth's crust compared to bauxite and aluminum or compared to iron ore. Nevertheless, that doesn't mean that we necessarily will have no problems at all as far as the metals are concerned in the future. It simply says to look at the problem of exhaustion as a pot that we're drawing out of over time is the wrong way of doing it. The real question is what's going to happen to metal costs over time, and are they going to rise to the point where we can no longer afford to use metals for automobiles and refrigerators and the other things we use metals for today? And the answer to that is not totally known at this point, because it depends on the one hand on the cost-reducing effects of technological change over time and the cost-increasing effects of depletion, which requires that we go to poor grade, more remote, more difficult to process mineral deposits. For the next 50 years, most mineral economists, most geologists are fairly convinced that we'll have no serious problems in terms of rising costs of metal commodities, rising real costs after you adjust for inflation. Beyond that, it's basically a race between the cost-reducing effects of new technology and the cost-increasing effects of depletion, and no one knows for certain which of those two will win the race. In the past, over the last 100 years, we do know that new technology has more than offset the increasing costs of depletion, and today copper and aluminum and many of our other metal commodities cost far less than they did 50 or 100 years ago. Whether that'll be the case in the future, we don't know. But we do know that the problem is not going to fall on us just one day we'll wake up and find we have no more metals. That won't happen. What conceivably could happen is that very slowly, over tens of years, over centuries, the real costs of metals rise slowly. However, that's far from certain. There are a number of forces at work that are tending to keep the costs of metals from rising to the point where we can no longer afford to use them.
Of course, these costs you're talking about apply in the West. What happens to the other part of the world, that huge number of people who still haven't had their first industrial revolution? Are they going to be able to get all the metals they want, and are they going to be able to afford them?
They'll be able to get them at the same price that the people in the West can get them. At the present time, for many people in the world, that means they're not getting very much in the way of metal commodities. And that's basically the problem of the distribution of wealth between the have nations and the have-nots. That's been with us for a long time, and it's likely to be with us for a while yet in the future. But that's basically a different problem. That's a question of how the wealth of this world is distributed among people rather than whether or not metal resources are too expensive.
In the future, if we're looking at increased use of metals by other peoples in the world, apart from the Western nations, there are environmental costs involved there, aren't there? What about the people who fear the degradation of the planet if the present rate of extraction of metals continues? Is that a subject that worries you?
Certainly that's a subject of concern to all people who are associated with the mineral industries. The mineral industries, by their very nature, have major environmental problems associated with them. But because of this, over the years, these industries have worked very hard to try and improve their environmental impacts. And if we are willing to pay the cost, there's no question we can have the mineral materials we need and contain the environmental problems associated with mining and processing of mineral and metal commodities.
Do you think the world can be persuaded to pay that cost of preserving what there is left of our planet?
Sure. It's just a question of what we consider to be important. And as the environmental issues come more and more to the attention of people around the world, I think it's only a question of time before they're prepared to pay the cost to keep the Earth's environment in a way that's attractive and pleasant for people who live here.
Out of the Fiery Furnace is brought to you by a company that makes aluminum for transportation, construction, and manufacturers of consumer products all around your house. Commonwealth Aluminum.
The companion book, Out of the Fiery Furnace by Robert Raymond, is published by the Penn State Press and is available at bookstores throughout the country.